Hi, this is your lucky sir. Here is a question, very interesting. 100 gram of sucrose solution in water is cooled to minus 0.5 degrees Celsius. The weight of ice would be separated at this temperature if solution started to freeze at minus 0.38 degrees Celsius. Kf water is given as 1.86 Kelvin kilogram per liter. 216.2, 150, 21.62, 93 grams are the options. This is very, very interesting actually, because already ice started, that is freezing is started at minus 0.38 degrees Celsius. Now how much of ice would be separated, he is asking, at minus 0.5 degrees Celsius. That means whatever the pure solvent was there, that means in a solution whatever the amount of solvent was there, in that solvent amount some part is going to be converted into ice before reaching this minus 0.5 degrees Celsius, and he is asking how much of that is. In order to avoid your time wastage, I have answered this question. I just explain you this. See, first of all, from the first condition is it started freezing at 0.38 degrees Celsius. So minus 0.38. That means delta TF is going to be 0.38 degrees Celsius. Kf is given as 1.86 Kelvin kilogram per mole. Mass of the solution is given as 100 grams, right? Mass of solution is 100 grams. That means in that x grams of solute is there and 100 minus x grams of solvent is there. X grams, 100 minus x grams. According to the concept of delta TF is equals to Kf into m, our regular formula. Here delta TF is 0.38, Kf is 1.86. In place of molality, I am writing here mass by molar mass into 1000 by mass of solvent. Regular formula. Molality is equal to mass by molar mass into 1000 by mass of solvent. Very regular formula. See, 0.38 I have mentioned here, 1.86. Here I have taken mass of the solute is x. This x I am taking. Here it is 342 because this is sucrose solution. Sucrose molar mass is 342. In the question sucrose is mentioned. 1000 by, in place of mass of solvent I mentioned here 100 minus 6. If you solve this equation by taking 0.38 and 342 here and 100 minus 6, so that will become 12996 minus 129. This I have made here some simple calculation. You will be getting x as 6.53 grams. That means this is the mass of the solute, mass of the sucrose, 6.53 grams. It is going to be as it is. It is not going to become solid. Okay, now it is 6.53 grams which is dissolved in that one. So mass of the solvent is, overall mass is 100 grams. In that 6.53 is subtracted, so that 93.47 grams is mass of solvent. That is water mass. Clear. Now you got 6.53 grams. 6.53 grams won't go anywhere. Okay, now the same 6.53 grams will be there even at next case, that is second case, that is at 0.5 degrees Celsius. Temperature reduced to minus 0.5. That means delta TF is going to be 0.5. 1.86 again constant. Now here I am taking 6.53 because this is the mass of the sucrose. 342 same into 1000 by mass of solvent. Here mass of solvent we are going to calculate. For example, mass of solvent, for example, you are getting some 50 grams. Initially it was 93.47. Now it is 50 grams, means whatever the difference is there, that difference is converted into ice. This is a wonderful, wonderful question. Whatever the difference you are saying here, that difference is ice. Okay, so by solving this, mass of solvent you are getting here 71.02. You can check with calculator, no problem. 71.02. Initial mass is 93.47. Now the mass of the solvent is 71.02. So whatever the difference is there, that difference is, here I got 22.45. In that options it was around 21 something. 22.45 grams is converted into ice. First solvent mass is 93.47. Second solvent mass is 71. So whatever the difference is there, that difference is nothing but ice formed. Wonderful question. Thank you all.